Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Krishna Saraswat, who holds a Masters and Ph.D. from Stanford, where he is currently an electrical engineering professor. How are you doing today?
I'm doing fine, thank you.
Thank you for joining me on the podcast. So, to start off, I wanted to ask what made you choose your major for your bachelor's?
Oh, that's an old story. So I grew up in India. My father was a professor of zoology. And as a high school student, I really wanted to do physics. And he said, son, you do physics, the only job you will ever have will be teaching job. And in India in those days, the salary of professors was not too good. It was pretty bad, actually. So he said, do electronics. And he had been to America as a visiting professor, so he knew the power of electronics. And he said, electronics is application of physics, so you go do it. So I changed my ideas and went into electronics. Although in India, there was no demand of electronics. No, this is in early 60s. So when I chose to do electronics, that was a shock to my friends who all went for mechanical engineering and civil engineering.
So, what was your
That's
experience
the
like while getting
story.
your bachelor's?
During my bachelor's, so I, in my higher secondary or what is known in this country, high school examination, I was number one student in the entire state of Rajasthan. And people were really surprised as to why I chose electronics. And within the institute, I used to get lots of good points for being the topper in the high school. So I did not really have to work very hard. But I worked hard, but not very hard.
Yeah.
And well, that propelled me to finish my bachelor's and come immediately to Stanford.
Yeah. So, what was the application process back then for coming to the US for a master's?
Oh, in those days, I did not even know that there were these exams like TOEFL and GRE. And at that time, my father was out in America, so I had to do everything on my own. Uh, so I went to Delhi, and the place where the GRE was being taken, this was in summer, their windows open, and it was very noisy. So I did what I could do. There was some portion with the verbal part, and I couldn't hear the loudspeaker. But I did okay. I ended up at Stanford.
Yeah. So, what was your experience like while getting your master's? And did you already decide that you want to do a PhD when you came here, or did that come later?
No, that came later. So I did my master's, and TI offered me a job. I didn't really ask what I will be doing. As 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 far as the job pays me, luckily it was in semiconductors, in microwave transistors, which was pretty close to what I wanted to do anyway. So I went there, but my job was in it was not in research, it was in manufacturing. And I wanted to be in research. And I was told that you have to have a PhD. So I applied back to Stanford and came back here. After that, TI really wanted me to come back, but I wanted to teach in the footsteps of my father and grandfather. So I stayed back at Stanford.
So, what was your research about while getting your PhD?
Oh, PhD research was very interesting. My co-advisor, John Linville, his daughter was blind, and the only way she could read any material was on Braille. So he came up with an idea to have an optical sensor which senses the written material and converts into tactile vibrations on a matrix of pins. So there was a huge group, and my PhD was developing high voltage MOS transistors which would drive those ultrasonic pins. So it was basically developing new devices which had the capability beyond what was available in the market.
So, how far along in your PhD did you make the decision to stay in academia rather than going back to industry?
Uh, at the end of my PhD, Texas Instruments wanted me to come back, and so I went to my advisor. His name was Jim Mindel. Uh, so, gee, these guys are asking me to go back. What is your advice? He had joined only 5 or 6 years ago Stanford from U.S. Army Electronics Command, and he was expanding his group. And he really wanted me to stay back. So he said, "Why don't you stay back as a postdoctoral researcher?" I said, "Great." So his responsibility was to bring the money, and my responsibility was to do research, which was a great thing. So I stayed back as a research associate, stayed back for 6 years in a research capacity, and then became a faculty member.
Yeah. So, how has Stanford changed from, or what year did you start being a professor?
Sorry, what is why?
Or what year did you start being a professor?
What did I do?
Or what year did you start?
Year 1983.
So, how has Stanford changed between then and now?
So when I came to Silicon Valley, it was, I just gave a talk yesterday on this topic locally in Palo Alto. This whole Bay Area, especially Stanford and surrounding area, were mostly uh, green farming communities. Saratoga, where I live, was absolutely green farming community with lots of fruit trees or orchards and things like that. Although Stanford was surrounded by Palo Alto, so all the facilities of a large town were existing. So the students who were staying in the dorms had a chance to go to Palo Alto and other nearby cities and have some idea of what are the things offered by a larger city. And San Francisco was only 30 miles away. So if they really wanted to be in a big city, they could just drive or take a train to San Francisco.
And then obviously San Francisco today is like a massive city. And uh, how much has Palo Alto changed?
Well, Stanford and Palo Alto have grown together. So lots of so Stanford was built by this guy, not built. Modern Stanford, with the emphasis on research, there was a professor by the name of Fred Terman, who later on became the dean and the provost. He propelled Stanford from a medium university to a world-class university by bringing in lots of famous researchers from companies like Bell Labs and Fairchild and so on, giving them incentives, uh, advising his students like Hewlett and Packard to stay in the Bay Area. Stanford had a land of something like 10,000 acres. They could not sell that land as was uh, given by the people who endowed it. So he gave that land almost free to the famous scientists from other organizations and asked them to come to Stanford. And they developed the curriculum, the research labs, and so on. And within a couple of decades, by the time I came there, Stanford was in the top five. And very soon, it became the top engineering school. And currently, in almost every discipline, it comes in the top three, largely because of the vision of Fred Terman.
And what year did he do all of that?
What did I do?
Or what year did Fred Terman do all of that?
Oh, Fred Terman, he he was a professor during 40s and 50s. By the time 60s came in, he retired. At that time, there was a policy that if you are 65 years, you have to retire, and he happily retired. Today, that's not the policies. If you are a tenured professor, you can go forever till you think that you are going to retire.
So next, I want to talk about what your research was at when you joined the university and how it's evolved since then.
You are asking for my research.
Yeah,
Oh, so I am a person who works in an area which is at least 10 years ahead of the industry. Because if you are working on the same things what the industry is working on, you are competing with them and they have many more resources. Whereas industry looks to us to work on future ideas which may or may not be good and give them the results. So my uh, work always has been on futuristic ideas, and mostly it has been semiconductor devices, optoelectronic devices, and solar cells. So far, I keep changing the areas, but those are the broad areas I have worked on.
yeah. Can you talk a little more specifically about the research?
So, as I said, my PhD was in high voltage transistors, but as a postdoctoral research associate, I worked on modeling of the fabrication processes. Uh, there were no computer programs to simulate the actual fabrication process. So, together with a few colleagues under the guidance of Jim Mindel and another professor, Bob Dutton, we worked on computer-aided design of fabrication process. And outcome of that was a program called Supreme, which was later on transferred to the industry. And now everybody uses it under a different name now. It is commercialized. So today, if you have to develop a product, you really have to use simulation tools like Supreme. So that's what I worked on. But later on, I went back to devices and what connects the devices in an integrated circuit, the so-called interconnects, the metal lines and so on. Uh, after working on that, I got interested in photonics for optoelectronic interconnects. And then lately, last 10 years, I have become interested in solar cells and very futuristic electronic devices. My interest keeps changing just to stay ahead of the industry.
Yeah. So for how research is structured in general, not just electrical engineering research, how has that changed over the last like 30, 40 years?
So, 30, 40 years ago, lots of basic research was done by the industry also. There used to be an entity called Bell Laboratories, and companies like IBM and others did lots of fundamental research. So, transistor invention was done at Bell Labs. Similarly, laser was invented in Bell Labs. Bell Labs became too dominant, so the government broke them down and they never came back to their prominence. And gradually, industry's focus shifted to shorter range research to develop products so they can be competitive. And that function of long range research has come back to universities. And those are many of those ideas were pioneered by Fred Terman in late 40s and 50s.
Yeah. So if there's someone who's undergraduate at Stanford today, I was wondering what could they do if they're interested in renewable energy such as solar?
So, first of all, to get admission at Stanford, you don't get admitted to a department. You are given 2 years. You take all kind of courses in technology, science, humanities, economics, etc. And then you decide, not the university. Unlike many other universities, my older son went to USC, where you had to choose right away at the time of admission, and you cannot change. Stanford says, come here, look at various opportunities, and then decide. And as a result, the Stanford education becomes very broad. And the students, by the time they finish their bachelor's, their ideas may be very different than the time they came. Um, and during Masters and PhD, especially PhD, they are fully supported by the university in terms of economics. So if I take a student, I have to pay all the expenses, both the research expenses and the living expenses of the student. That's a requirement at Stanford. Other universities don't have that luxury because they may not have that kind of resources. Did I answer your question fully or?
Uh, that was kind of the first part, but then um, if a student was interested in renewable energies, such as solar, are there
Oh,
any
yeah.
programs you know of which they could be involved in?
So solar energy is an area which is distributed in many departments. So material science, for example, looks at the solar cells. Electrical engineering looks at the system level. And then there are other departments like chemical engineering and physics. They also have. Luckily, Stanford allows multi department collaboration without any kind of boundaries between departments, which is not the case in many other universities. Two professors don't really collaborate in other universities. Here, we promote that. So, depending upon your interest, whether you are interested in the material part of it, or device part of it, or the system part of it, uh, you can choose the department and the area and the professor. And there are plenty of opportunities.
Do you know of any specific ones?
Well, we have a complete center which looks into renewable energy. If you go to the website of Stanford, you can get more details. I'll send you the information if you need that. But uh, but in each department, there is lots of activity. So again, it depends upon your interest.
Yeah. So I know Stanford, along with many other universities, have a makerspace. Are there any interesting projects you've seen students work on there?
In which area?
The makerspace?
Makerspace. Okay. So makerspace is more for undergraduate students. So after you finish you're in high school, right?
Yeah.
So after you finish in high school, you come to Stanford, and then there will be lots of projects which are generally aimed at undergraduate students to get them interested in engineering. And it could be a solar cell, it could be an electric car, it could be some new kind of appliance which somebody could use at home. And those depend upon the interests of the faculty. And since the faculty size is large and student body is not as large, students work directly with the faculty on pursuing many of these projects, and they are very interesting.
Yeah. Um, are there any particular student groups or organizations that you're interested in?
I am interested in, so there are, at different times, I have been interested in different groups. For example, the summer opportunities for undergrad students who may be at other universities who want to come to Stanford to explore. I have been always a member of that. The solar part, of course, I'm working with many both undergrad and graduate students now. Uh, Manufacturing is an area. where now we are realizing that America should be doing more manufacturing of semiconductors. So I'm part of that group as well. And wherever the opportunities come, interaction with the industry. I have been involved in that since I would say 1990 or so. Encourage industry to come to Stanford, work with our students and faculty, take the results of our research and implement that in their products.
Mhm.
So that's a totally different area.
Yeah. So I know companies such as Apple and SpaceX sponsor many classes at Stanford. Can you talk a little bit about that?
So they generally they sponsor more in terms of projects. These could be research projects, or these could be class projects. Sometimes we invite people from companies like Google and Apple and other companies to come and give guest lectures. At times, they may be actually teaching full courses. Some of my former students work for companies which make equipment, or they may work for companies which make software and so on. So sometimes when we don't have that expertise, we invite them to spend a quarter or so and teach a course. Many of these courses could be online, means the students could attend. The teacher doesn't have to drive to Stanford and park and this and that and put in lots of time. So they could teach it from wherever they are. And that's not very common, but it is done.
Yeah. So to end off the podcast, I have two big questions. The first one is what's your biggest piece of advice for someone who's going to be an undergrad at your university?
So my advice to students is that follow your passion. If you think, like I was interested in physics and changed it to electronics, and there were no jobs in India, but I was very passionate about physics and its applications, and I followed it, and it paid off very handsomely. So follow your passion. In doing so, Stanford is one of the best places because we give you 2 years to find out what is your passion. Other universities may not do that. If you know exactly what you want to do, fine. In that case, you can go anywhere. So that was number one. What was the second question? I
Yeah.
forget.
And my second question is what's your biggest piece of advice for someone who wants to go down a similar career path as you into academia?
So academic paths is a very difficult path. Uh, when you finish your PhD, you have to have a PhD. Or if you want to go teach in the business school, you have to have an MBA. So first of all, you have to get good education with very visible contributions. So if you're a PhD, you must have published papers in good journals. And if you want to be in a good universities like Stanford or MIT or Berkeley, then they look at how good were your contributions. Then can you teach? How good you are as a teacher. Third thing is how good would you be in interacting with the funding agencies and bring money to the university? Because for graduate education, the professor provides funding to the students, not the university. So those are kind of things. Uh, Generally, students finish their PhD, and like me, they spent some time as a postdoctoral researcher to show their independence from their advisor and to show that they can come up with the new ideas which are far-reaching and contribute there. So my advice is to spend a year or two in another university under another professor and make solid contributions and then apply for a teaching job. And if you are interested just in teaching, you could go anywhere. But if you are interested in research also, you have to go in a top grade university, in the top 10 or top 20 universities in that field.
All right, then. Thank you for joining me on the podcast.
Very welcome. Thank you for giving me an opportunity.